Good day, my name is Az Salamaranya, PECE third year section R. So I'm here with you to discuss the plate number 10-1D. That is all about the analysis and the design of the eccentrically loaded short column. So please be with me as I discuss the possible answer. Thank you. So the problem number 1 is finding the load combination of the axial load and the moment strength for the tied column. So we are assigned in the sub question, which is D, that has the given of the steel strain of 0.055. So first of all, we need to find the C, or the balance C, so which is the distance from the extreme compression fiber to the neutral axis, so probably here. So to find this C, we need to use this equation. So C over the concrete strain equals D over the steel strain. So and substitute all the given data. So C over the 0.003, which is constant, the concrete strain, equals the 450, which is the distance from the extreme compression to the centroid of tension reinforcement, so from here to here. So the result is C is equals to 245.45 millimeter. So again, we are already find the distance from the extreme compression fiber to the neutral axis, which is C. We need to proceed to the finding of A, which is the equivalent stress block, which has the formula of B1 times C. So since our problem has the specified, the compression stress of 28 megapascal, so lower than 30 megapascal, so we use the 0.85. so 0.85 ang B1 times the C, which is 245.45. so our A now, which is the equivalent stress block, is 208.63 millimeter. So to check if the steel yields, so we need to use this equation, which is ES prime over C minus D prime equals EC over C. Substitute all the given required data. So C mana na siya equals the concrete strain with 0.003 and our value of C, which is 245.45. so our ES prime now is 0.002, which is lesser than the given steel strain, which is 0.005. so we conclude that the steel does not yield. So the stress in compression steel is not equal to the specified yield strength. So the stress in compression steel, we need to use this equation. So 600 times the C minus D prime over C. So substitute all the data. So 600 times the C, which is 245.45, minus the D prime, which is the distance from the extreme compression to the centroid of the compression reinforcement. So kanang like here, this distance. So the Fs prime now is equivalent to 416.66 megapascal. We proceed to the determining the forces. So let's start with the tensile force in steel, so T1. So we need to use this formula, which is the area of steel times the specified yield strength. So this one is T1. So substitute the area of circle, which is the steel, the pi times the diameter of 25 squared over 4 times 3 because 3 ang steels ni Janhe times the yield strength, which is 420 that is given in the problem. So equate. So the T1 now is 618.5 kilonewton. Now we proceed to the T2, the tensile force 2. So maghapon ang area. A is AS times Fy. So substitute the area times 2. Anong 2 man? Kay 2 raman ang iyang koan. Nasakop. Times the specified yield strength is 420. So T2 now is 412.3 kilonewton. We proceed to the compressive force in concrete, which has the formula of 0.85 times the compression stress times the equivalent stress block, which is E times P, distance P. So apply all the values, 0.85 times the 28 megapascal that is given in the formula times the 208.63, which we found earlier, which is here the 200.63 millimeter times the distance of 300. So mga anihi mo na ang B. 300. So equate. So the CC now is equivalent to 1489.62 kilonewton. And now we will now proceed to find the C1 and the C2. So to find the compressive force of steel 1, we need to use this formula, the stress in compression steel minus 0.85 times the compression stress times the area of the AS prime, which is the compression of the reinforcement steel. So equate all the data. So our stress in compression steel earlier, so kani man ni siya is 416.66 megapascal. So ato siyang i-substitute minus 0.85 times the 28 megapascal that was given from the problem times the area of steel, the area of the compression steel, which is pi over 4 times 25, which is the diameter squared times 3. So our compressive force in steel 1 is equivalent to 578.53 kilonewton. So we proceed in the compressive force in steel 2. So mora gihapon ang formula, but they differ in the area of the steel since mao man ni siya ang kanina namang tuha. So equate all the values. So 416.66 minus 0.85 times 28 megapascal times the area of pi over 4 times 25 diameter squared times 2 reinforcement steel. So the C2 is equivalent to 385.689 kilonewton. So we will balance all the loads. So Pn plus the tensile force 1 plus T2 equals the compressive force in steel 1 plus the compressive force in steel 2 plus the compressive force in concrete. So substitute all the values from here. So Pn plus 618.5, which is the T1, plus 412.3, which is the T2, equals to equals 578.53 plus 385.689 plus 1,489.62. So our Pn now is equivalent to 1,423.04 kilonewton. So manasidya. And now we will now proceeding the balance of the eccentricity. So we will now start here from this formula. So Pn times the E plus 187.5 equals to the compressive force in concrete times D minus A over 2 plus the compressive force in steel 1 times the D minus D prime plus compressive force in steel 2 times 250. So substitute the Pn which is the 1423.04 times E plus 187.5 is equals to 1489.62 times the D, which is 450 minus the 208.63 over 2 plus 578.53 times 450, which is the D, minus 75, which is the D prime, plus 385, which is the compressive force in steel 2, times the 250. Our intrinsicity is equal to 394.57. So our eggshell load now, so our eggshell is kanang the 1423.04 times 0.65 is equivalent to 924.976 kilonewton. So this is our eggshell load, and our moment strength is, we need to use this value. So 924.976 kilonewton times 394.57 millimeter. So our answer is 364.907 kilonewton meter. So this is the final answer. Thank you and God bless.